count the annual layers. Since they're so sharp, it's hard to believe that they're not synchronous. So these are something that happened, boom, the system reorganized. And now, when I was first confronted with this, I was wondering what was the cause of the climate changes, and I put my finger on the thermohaline circulation in the Atlantic. Right now, there's a volume of water flowing mainly through the Gulf Stream up into the northern Atlantic that's equal to about maybe 70, not 100 Amazon rivers, but 70, something like 15 million cubic meters a second. That's equal to all the rain in the world. It's a lot of water. And that water carries heat up there. Initially, I thought that these events were caused by turning on and off of that heat. This guy right here, with one side, showed that was probably wrong, that it wasn't the heat, and he made a tombstone that said, from that haline circulation is dead. Well, didn't quite say that, but he meant that. He writes these terrible papers about that. He's right about that the heat doesn't do it. But what he forgot about, and we forgot about, is if during cold times you turn that heat that's going up there off, you may not change the climate in Europe very much, but you're allowed to freeze over. And so we're quite convinced now that during these very cold times, there's sea ice, which is now, let's see if I have that. Yeah, the sea ice on March 1st, 2004, which would be the maximum for that year, is shown on one side, and on the other side is sort of our suspicion as to where the winter sea ice extended during these very cold periods. And herein lies the answer as to why these climate changes were so big. And also, it indicates that we've lucked out, and if this great circulation system were shut down or weakened, we wouldn't have the kind of impacts in the future that we had in the past. So the system is not symmetrical in that respect. And that is, if it happened in the future, the sea ice wouldn't form. But we were really puzzled for, I suppose, 20 years. Nobody could explain why. I mean, Richard would say even the heat, the part that we were trying to explain, which was Northern Europe and Greenland, wouldn't be affected that much by turning the heat on and off. But if you make sea ice, which is we have, I think, pretty good case now that that's what happened. John Chang, who was a student, who got his PhD here with Mark Chang, and now is a professor at Berkeley, showed that, at least in models, if you put this sea ice in, it opens the door of explaining all the evidence we see. It's consistent with all the evidence. And what he showed first was that, of course, if you put that sea ice in, you talk about the north, you make everything from Canada around to Siberia like Siberia, because there's no heat any longer coming out of the ocean. Can't get through the ice. And of course, the ice is very reflective, so you lose some of the solar radiation. He then showed that, so that would explain why Europe got very, very cold during the winters in these cold phases. Then he showed that if you put ice in the north, it pushes the tropical rain belt southward. It pushes the thermal equator to the south. So the thermal equator would be where you stop getting warmer in a sense, and you start getting cooler as you cross the tropics. And of course, the rain belt is moving seasonally back and forth. And so if you shift the thermal equator, you shift this rain belt. If east to the south, because you make the northern hemisphere colder than the southern hemisphere. And that explains a number of the records. And it explains them by saying that what you're seeing is not a change in temperature necessarily, but a change in rainfall. Then a guy named Barnett at Scripps had written a paper earlier which sort of said if you could make the region of northern Europe and Asia even colder, you would preserve snowfall longer in the spring, and that would delay the heating of the Tibetan Plateau and the continents in general, and it would weaken the monsoons. And some of these records clearly show that the colder it was, the weaker the monsoons were. Now, I said that in the future, I don't know if this is probably not a big deal. I'm not sure that global warming could shut down the conveyor. And if it did, we wouldn't get sea ice. It would be too warm. It would take a 6-degree warming or something to shut it down. But what this whole thing shows us is that the Earth's climate system is quantized, in a sense. And there are interactions between the atmosphere and ocean that are very important. And the ocean it's important in the climate record because the time between these sharp changes is on the order of 500 to 800 years. And you have to have some way to track the climate system in a given state. And the atmosphere has no memory. You can't do it with the atmosphere. You've got to have ice or ocean. So that if you, to explain what happened in the past, you have to call on some interaction between the atmosphere and the ocean. And since we don't have any record of what it would be like if we warmed the planet 4 or 5 degrees, we can't be sure that there are not comparable things that will happen that affect rainfall or anything. I don't think we can make any prediction at all as to whether this phenomenon of jumping from one state to another could happen, but we certainly have to have it in our mind that it might happen. So I personally feel that as stewards of the planet, we shouldn't do this experiment. And unless we take some really serious action, and that's far more than driving Priuses and insulating our houses. It couldn't mean taking CO2 back out of the air or preventing it from going into the air because the world is going to burn a lot more fossil fuels. And if we just continue along the present path, we're headed for 900 parts per million, we're headed for maybe 5-6 degree warming. This is going to change wildlife everywhere on the planet and leave behind some species that won't be able to make the transition. So I think as stewards of the planet, just to get cheap energy, we don't have the right to do that. So if there is a way to stop this, we should do it. And unfortunately, I see no way to stop it at less than double. So we're going to experience double, and we'll see what that does. And so I think that if we work at it, we could stop it at doubling. If we do little more than we are now, it's going to triple or more because the developing countries are going to start to use more and more and more energy, and it's going to come, like all energy on the planet, primarily from burning fossil fuels. We've got enough coal to run the planet for 300 years or something, and coal can be converted to gasoline at a fairly low cost. So even if we run out of oil, not much trouble as far as running vehicles. So I think I'll stop there. You want to take questions now or later? Because I'm going to leave. I have to leave. Okay. So if you want me to answer questions, I should go down. Take questions from Molly now and then for one. Yeah, I'm sorry.